Next example is about a DC machine that is being operated as a shunt generator at no load. Determine the maximum value of the generated voltage. So, what will be the maximum value of the generated voltage? For this, we know for a shunt generator, V terminal equals to EA minus IA RA. And when it is a no load condition, that means the generator, no current is flowing outside the generator of the. So, it will be approximately equals to EA. What will be the internally generated voltage will be actually out um, as at the terminal. Now it this question is saying that the DC machine example 4.2. So in example 4.2, this was the magnetization curve of the machine. So if you look at this curve, what it is now asking is that what will be its value for this machine. Now, for this machine, we know that that this is a self-excited or shunt generator. So we have the field winding, which is composed of field winding internal resistance or are adjustable. So the maximum voltage that will be maximum value will be generated when the maximum current IF will be flowing through it, and maximum value IF will flow through it when R adjustable equals to 0 and the only resistance in the field winding is of its is the natural resistance of the field winding. So what will be the maximum field current, what will be the value of the field winding resistance, that we can see from here. It is given that it is 80 ohms. Example 4.2, it's 80 ohms. So for 80 ohms, RF equals to 80 ohms, maximum EA will be induced. So if we have this curve and we have to draw a line that has a slope of 80 ohms. So let's see, how can we get, if the voltage is 80 volts divided by 1 volt is 80 ohms. For example, 80 volts divided by 1 ampere is actually 80 ohms. So the slope of this line will be actually our 80 ohms line. This is 80 ohms line, and this will approximately become equal to 111 volts. So the value of maximum internal value, that voltage that will be generated by intersecting the line will be 111 volts. Now the second part states that determine the value of the field control resistance RFC, that is actually R adjustable or field control. It is this resistance they are talking about, required to generate the terminal voltage. Now remember, this is no load condition, so whatever the induced voltage is the terminal voltage. So the rated voltage for our machine is that is given here is 100 volts. So what it is asking is, what will be the value in which what will be the value of the field resistance, that is equals to field winding plus R adjustable. What will be the value of this resistance that will intersect, when we will draw this line, it will intersect the curve at 100 volts. So to get the 100 volts, if we go to the curve and we find out, this is for example 100, so this is actually uh, this line, it is talking about this line. So this line will be actually 100 volts divided by 1 ampere, that is 100 ohms. So the total field resistance that we will be requiring will be 100 ohms, and we know the value of this is 80 ohms. So field control resistors or are adjustable, that is actually our field control is equals to 20 ohms. So if we'll set it to 20 ohms, we will get 100 volts at the output. And the last question is related to determine the value of the critical field circuit resistance. Now the critical field circuit resistance for a self-excited or a shunt generator is actually, when we draw a line, let's change the color for this line, let's make it blue, is actually, it is parallel to this line. And if we look at this, it is parallel to the linear circuit of the line. And if we assume that, for example, to get the value, exact value for the slope, and wait, it is, and we take this value, so this becomes here something, this value, say this is 85 volts. So you can say that this point will be, the slope of this line is actually 85 divided by 0.5, and this will, for the part C, for the critical field resistance value, we can say the value of the resistance will be RF critical, if we, from the curve, 85 divided by 0.5 amperes, and this becomes 170 ohms. So now this value is 170 is 170 ohms is actually equals to field winding resistance plus R adjustable resistance. So R adjustable will actually becomes to, this is 80 ohms, that is internal. So R adjustable is actually equals to 90 ohms. This means, what is the meaning of this critical resistance? This critical resistance means that the self-excitation, this is the borderline. If we will move towards this area, the slope will decrease, the slope will be decreasing. So this means that this area where the self-excitation is possible, and the value of field resistance will determine how much will be the maximum value. But if we go beyond this, the value of field resistance, the generator will not be excited because no field current will be flowing through it to create self-excitation effect. I hope it helps. Thank you.